Differentiation. So differentiation is one of the important topics in calculus and even pre-calculus. So differentiation is the rate of change of y with respect to x. So imagine I have this line. So this is the y-axis and this is the x-axis, and this is a blue straight line. So I have 2 points on the line. The first point is x1, y1, while the second point is x2, y2. So these are the coordinates of the 2 points. Now, if I want to find the rate of change of y, so y, with respect to x, simply we find the slope or the gradient, which is y2 minus y1 over x2 minus x1. So to find the rate of change of y with respect to x, I have to find the gradient of the straight line, which is y2 minus y1 divided by x2 minus x1. So I have to have 2 points. Now, since differentiation is the rate of change of y with respect to x, and the gradient is also the rate of change of y with respect to x, I can simply say that the gradient, which is the derivative, which is usually denoted by dy over dx or f prime of x, is equal to the gradient. So the result of differentiating functions is called the derivative function, and the derivative function is called dy over dx or f prime of x is equal to the gradient. So the gradient and dy over dx is the rate of change of y with respect to x. Now, to find the derivative function, we have to use this simple rule. So the original power multiplies the expression and the power gets reduced by 1. So if I have a function f of x, which is x to the power of n, to find f prime of x or dy over dx, which is the derivative function, I have to multiply n by the expression here. In this case it is 1 because it's only x to the power of n, which means it's 1x to the power of n. So it's n times 1, which is n, x remains, and then I have to reduce the power, which is n by 1. So that's why it's n minus 1. So f prime of x is n times x to the power of n minus 1. So that's our rule. Now let's have this example. It says find the derived function of y equals x to the power of 5, y equals 2 times x to the power of negative 1, and y equals 3x squared minus 5x plus 6. Now let's start with the first one. So it's y equals x to the power of 5. So to find the derivative function, it's dy over dx. So I have to multiply the power by the expression. In this case it is 1 because it's 1x to the power of 5. So 5 times 1 is 5x, and then I have to reduce the power by 1. So 5, it becomes 5 minus 1. So the answer is 5x to the power of 4. For the second one, again, dy over dx is equal to, I need to multiply the power, which is negative 1, times the expression here, and it's equal to 2. So negative 1 times 2 is negative 2x, and then I have to reduce the power by 1. So I have here negative 1, again reduce it by 1, so again negative 1, so negative 1 is negative 2. So dy over dx is negative 2x to the power of negative 2. The last one, so I have dy over dx, again I need to multiply the power, which is 2, by the expression. So it becomes 2 times 3, which is 6x. Then I have to reduce the power by 1. So it's 3x squared, the power is 2, reduced by 1, it becomes 1 because 2 minus 1 is 1. So it's 6x to the power of 1. Minus. Now 5x. Now the power of x here is 1. So I multiplied by the expression which is negative 5. So 1 times negative 5 is negative 5. X. Since the power is 1, I have to reduce it again by 1. So 1 minus 1 is 0. And what's left is plus 6. Now always the derivative of any constant is always 0. So here the constant is 6. The derivative of 6 is 0. Now let's simplify. So it's 6x to the power of 1 is 6x. Now x to the power of 0 is 1 because anything to the power of 0 is 1. So it's minus 5 times 1, which is minus 5, and 0 is nothing. So my final answer is 6x minus 5.